Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to use the Pythagorean theorem to find the missing sides of right triangles. Don't forget, we have some practice problems at the end of this presentation in order for you to demonstrate mastery of the contents of this tutorial. To get us started, let's take a look at what the Pythagorean theorem is, and then we're going to use it to solve some problems, okay? So here goes the Pythagorean theorem. If a right triangle has legs of lengths A and B, okay, and hypotenuse of length C, then we can come up with a conclusion. If we have this initial condition, a right triangle with legs of lengths A and B and hypotenuse of length C, then we have the equation a squared plus b squared equals c squared. Basically, the sum of the square of the legs is equal to the square of the hypotenuse. All right. So how do you identify the legs and the hypotenuse of a right triangle? The legs that we're going to call A and B are basically the two shorter sides of the right triangle. Okay? And then guess what? The hypotenuse, which we're calling C, is the longest side. Okay? The longest side of the right triangle. And something else to keep in mind is that the longest side is always opposite the 90-degree angle. That's an easy way to determine what the hypotenuse is. So let's just give you a visual of what we're talking about here. So let's say you have a right triangle. So that's a requirement, okay? The Pythagorean theorem only applies to right triangles. That's a initial condition. So let's say you have a right triangle right here. See, these are the two shorter sides, okay? These are the legs. So call this a leg and this is a leg. It doesn't matter what you call A and B, right? As long as they're the two shorter sides. Now you notice the side that's opposite the 90 degree. This is the hypotenuse C. All right? The 90-degree angle is the biggest angle in the right triangle. So the side opposite the biggest angle is the longest side. All right, so if you have a right triangle with this configuration, the sum of the square of the legs, a squared plus b squared, is equal to c squared. So that's your Pythagorean theorem. All right, so the instructions for the examples that we are going to be going over are as follows. We are to do the following. So for the given right triangles, this is what you're going to do. You're to identify the legs of the triangle and the hypotenuse. All right, so that's the first part. Identify the legs and the hypotenuse. And then when you're done doing that, you are to find the missing side. Okay, find the missing side. We're gonna call it X in this presentation. All right, so let's take a look at the first problem. All right, so for question 1, let's say we have a right triangle like this. And this is the right angle right here. This is X, 10, and 4. All right, so to get us started, we're going to look for the hypotenuse and legs. All right, the easiest one to identify is the hypotenuse. If you just take a look at this triangle, you can easily see that this is the longest side. Or think about the side that is opposite the 90-degree angle. Okay, right here. That's the longest side right there. So this is the hypotenuse. if this is the hypotenuse, these two are the legs. So let's call this the hypotenuse, which is C. All right. And then this would be a leg right here. This is a leg, which is B. And then this is another leg, which is A. It doesn't matter what you call A and B, but C is always the longest side. All right, so let's go ahead and write those down. Our hypotenuse for this problem are A equals 4 and B equals X, our unknown. And then our, no, these are the legs. So the legs are A equals 4 and B equals X. All right, and then the hypotenuse is C equals 10. Okay, all right, so now we're gonna find X. Let's go ahead and find what X is. So to find X, we're gonna start off by writing down the Pythagorean theorem. A squared plus B squared equals C squared. Okay, so first you write down the theorem and then you substitute, okay? Substitute your known and unknown values. A squared is 4 squared plus B squared is X squared equals C squared, which is 10 squared. All right, now we're left with an algebraic equation that we're going to solve for X. To solve this, we're going to start off by simplifying, all right, both sides of the equation. So what can we simplify here? We notice that the numbers are squared, so 4 squared is 16 plus X squared. Simplify the right side. 10 squared is 100. All right, so now we're going to collect like terms. We're going to move the numbers to the right side and leave the variable on the left. So to move the constant 16 to the left side, we use the inverse operation. We're going to subtract 16 from both sides of the equation, and that will yield X squared equals 84. All right, so how do we get rid of the square component there? We're going to use the inverse operation. Okay, the inverse of square is square root. So we take the square roots of both sides of the equation, and that will give us X is equal to root 84. Okay, so let's try and see if we can simplify root 84. Make a partition here. So we're going to break it down using prime factors. Any prime factor that repeats counts as a square. All right, so since this is even, we're going to take out 2. 2 goes into every even number. All right, 2 goes into 84 42 times, and this is also even, so take out another 2. 2 goes into 42 21 times. Okay, this is odd. 3 goes in here. 3 goes into 21 7 times. Do you see any perfect squares in the factorization of 84? Yeah, we have 2 times 2. That's a perfect square. 2 to the second power. All right. When you take the square root of that, you just have 2 to the first power. All right. The square root of 2 squared of 4 is just 2. 3 and 7 do not have enough power to take the root. Okay. They're just to the first power, so they're going to remain in the radical, in the radicand, as radicands. All right, so this is going to become 2, which is the square root of 2 times 2 is now comes out of the radical symbol. And then what stays behind are the other 2 factors, 3 times 7. They didn't have enough power to break out, so they stay behind. And then when you simplify that, it's going to be 3 times 7. Combine the 2 numbers in the radical symbol, 3 times 7, which is 21. Okay? So X in a simplified form is 2 root 21. So that is the measure of B in the right triangle right here. Okay, so just to show that it's solved, B, which is X, is 2 root 21. Okay, let's take a look at another example. Then we'll give you some practice problems to try out. So let's say we have a following right triangle. Okay, so for number 2, let's see, we have the following setup. This is a right angle right here. This is root 5. This is root 5. And this is 4. And this is x. Okay, so we're going to look for x. Before we do that, we're going to first of all determine what the legs and the hypotenuse are. So opposite the 90-degree angle is the longest side of the right triangle. So this side right here is your hypotenuse. Okay, so C is going to be the hypotenuse. And these two sides are your legs. So it doesn't matter what you call A or B. So let me just call the shorter side A. So this is a leg right here. And then this is another leg right here. Bam, bam. So let's go ahead and write them down for this triangle. The legs are A equals root 5 and B equals 4. And then your hypotenuse is C equals X, our unknown. All right, moving along, let's go ahead and find X. So to do this, we're going to use the Pythagorean theorem. First thing you do is write down the formula that will guide your problem solving process. A squared plus B squared equals C squared. And then you substitute, okay? So A is a radical, so root 5 squared plus B, which is 4 squared, equals C squared, which is X squared. Okay, so what is this right here, root 5 squared? We talked about this earlier in number 1. You notice when you took the square root of a square, these two operations canceled out. Okay, well, since square and square roots are inverses, regardless of the order, if you compose them with each other, they cancel each other out. All right, so if you take the square of a square root, they are going to cancel each other out. So we have 5 plus 4 squared 16 equals x squared. Okay, 5 plus 16 is 21 equals x squared. To get x by itself, we're going to get rid of the square by using the inverse operation, which is square root. So we're going to root both sides. Okay, and then we get x is equal to root 21. Now, is it reducible? Can we reduce root 21 into a simpler form? Let's try it out and see. So we have root 21. We're going to break it down into its prime factored state. So 21 is odd. 2 can go. Let's try 3. 3 goes into 21 7 times. So that's a prime number. So the decomposition of 21 is 3 times 7. None of these factors repeat, so there's no perfect square that can be extracted from the radical position. All right? So what does that mean? It means that root 21 is the simplest form of this number. Okay? So our answer x is equal to root 21. So C is root 21. All right, so now it's your turn to do some practice problems. All right, so here are 4 practice problems we'd like you to try out. Go ahead and pause the video presentation at this time and try out these practice problems. When you're done, click on the playback button, and we're going to reveal what the correct answers are. So quick adjustments to number 4. You have x root 2 and root 3. Okay, so go ahead and try it out. All right, so here goes the answers to questions 1 to 4. Go ahead and check your work. So how well did you do in these 4 practice problems? Let us know your score in the comment sections below. If you have any questions, let us know too. We'll be more than glad to assist you. Thanks so much for taking the time to support our channel by watching, and don't forget to support by giving us a thumbs up, commenting, and subscribing. If you know anyone who's struggling with algebra, geometry, or any high school math class, just direct them to our webpage or YouTube page. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching. We'll see you in the next video. Goodbye.